Yes, hi guys. Good evening. Yes, can you hear me? Yes, if anyone still unable to hear me, just rejoin. Anyone unable to hear me, just rejoin the session. Rejoin the session. Just rejoin the session. If anyone unable to hear me, just rejoin. Okay. Yeah. So let us start session. Yes, I hope everyone is online only. Yes. Yes. See, if anyone unable to hear me, just rejoin the session. Session started. Started. Yes, I'm speaking. Session started speaking. Yes, if anyone unable to hear me, just rejoin the session. Rejoin. Yes. Leave the session. Leave and rejoin. Leave the session and rejoin. Yes. Yeah. So let us start. So yesterday, day 2. Yes, 9 p.m. 9 p.m. Yes, day 2. So yesterday about Java. What is Java? The Java history discussed since 1995 to today. What was happened with Java? How Java has become later in the market? All that discussed. Because how Java has become later in the market? All that history discussed. Like different editions of Java also discussed. Different editions. Okay, all of this in discussed. History discussed, past discussed here. Now present also, what is present position of Java? Present position discussed, and Java feature, all that discussed yesterday. So you got some idea about Java. Okay, what was happening in Java? Now what is happening currently here? What will be happening in Java future? All that discussed. Okay, fine. Now let us start with Java features today. Today topic is C. JDK 1.0 released with main features as below. JDK 1.0 released with main features as below. Yes, these are topic today. Let us start with Java features. Okay. Yes. See here. Yes. Independent platform, portability, whoop language, security, scalability. These are the first initial features. Java released with these features. Okay. See here, to understand these features here, to understand all these features, some basics required. Basics. If you have that basic knowledge, then easy to understand these features here. Okay. See, I can explain directly. Simply explaining definitions and going to Java programming. But that is not my way. I'll explain very clearly and in depth. So for that purpose, yes, there are some prerequisites to understand these features here. Some basics required. Yet to understand about these features here, you need, yes, basics like OS concepts. Yes, what is operating system? How operating system is working? See, independent of platform. Platform means you see OS. How OS is working, that OS behavior. Okay, when you're running Java application, how OS is behaving. That OS knowledge. Okay. Next. Yes. Next, interpreters and compilers. Interpreters. Yes, interpreters and compilers. Interpreter and compiler. Yes, you must have this knowledge also to understand Java features here. Interpreter and compiler. Okay. Yes, what is OS? How OS is working? Next, interpreter and compiler knowledge. Yes, apart from this, next exe file and dot class files knowledge. Dot class file. Yes. So once you have this knowledge here, then easy to understand these features. Okay. So with this knowledge, you can understand these features. First, let us see how OS is working. Next, how interpreter and compiler working. Next, exe file dot class files. How these are working here. So let us see these things. After that, we'll go to Java features. To understand all these Java features, you need some basics. Now, I'm starting with basics. Yes, I'm starting with starting with basics. Starting with basics. Starting with basics. Here, these basics anyone can understand. Starting with basics, non-IT guys or everyone can understand here. Starting with very basics here. Okay. Yes, you guys may be wondering. Here may be wondering. I'm starting from very scratch. I'm starting from very scratch. Who are new to computer also can understand that level. I'm starting topics. Okay. Yes. There are some basics. These are some unknown facts. There are some fundamentals. Those are unknown facts. The guys who are already 10 years of experience in software field, they don't know about these basics. Okay, what are the basics I'm explaining here? 10 years of experience guys also, they don't know about these basics. Yes, let us see that. Okay, see, computer where? Yes, computer where? Computer where basically two categories. First one, hardware. First one hardware, next one software. Yes, you guys I think now is wondering. Okay, you guys are wondering. They started from very scratch. Okay, so why reason is there here? See, when you facing interview, every question you have to answer. That is my intention. Basics also you have to answer very clearly, including basics. Every question you have to answer. So further reason started from basics here. Hardware and software. Computer were basically two categories, hardware and software. Yes, hardware, these are physical components of a computer. Hardware, these are physical components. Physical components like mouse, monitor, keyboard, RAM, hard disk, motherboard, all the hardware components. They are the physical components. All these physical components. That physical components we can touch. We can touch all the physical components. 1 second. Yes, someone is struggling to join. Yes. Hardware and software. So hardware, these are physical components. We can touch all these parts, but this is not our parts. See, we are the software engineers. We are the software engineers. So let us start with software. So ours is a software. Let us start with software. So what is a software? What is software? So what is a software? See, in software, yes, everything is a program. Everything is a program. Everything is a program. In software, everything is a program. Yes. Yes, it is a collection of programs. It's a collection. It's a collection of programs. It's a collection of programs. It's a collection of programs such as some C program or C++ or Java or Python, something like this. It's a collection of all the programs. Okay, fine. It's a collection of programs. Fine. Here, software. The software basically two categories. Software, yes, basically two categories. Software basically two categories. two categories. Software basically two categories. Software basically two categories. First one, yes, system software. First one, system software. Software basically two categories. First one, system software. First one, second one, yes, application software. Second one, yes, application. Second one, application software. System software, next application. Software basically two categories. System software, next application software. Yes. What is a system software? Let us see about system software. What is system software? What is a system software? System software. System software. Yes. It interacts with hardware components. Interacts with hardware components. Hardware components. Interacts with hardware components. Okay. System software. System software. It interacts with the hardware components. Hardware components. System software. System software. It interacts with one. Interacts with the hardware components. Yes. System software. It interacts with hardware components. Yes. Example. System software examples. Yes. Operating system. Operating systems and device drivers. Of course, device drivers are part of OS. Okay. Yes. System software. System software. System software. It interacts with hardware components. System software. It interacts with hardware components. Yes. Example: operating systems and device drivers. Okay. Next, about application software. What is application software? See, application software. Application software. Here this is. Here this is for the purpose of application, or for the purpose of application development. Application for the purpose of application development. Application development for the purpose of application development. Okay. Yes. See, what is application software? This is for the purpose of application development. Application apps. There are different kinds of applications. Yes, in our daily life. See, in our daily life, using many applications, right? Yes, you guys. Anyone, can you tell me some examples? Yes, what are the applications using in daily life? See, in our daily life, we are using many applications. Now, presently, already we are using one app. Already we are using one app, right? Already we are using one app. Yes, that go to training is app, right? See, go to, yes, go to training. Yes, go to training, it's app, right? It's app. Go to training. Facebook is an application. Okay, Facebook is an application. Okay, next, Flipkart is an application. Flipkart is an application. Okay, Twitter is an application. Okay, yes, Google Pay is an application. Okay, yes, Amazon online services application. Okay, next, company websites are applications. Company websites, applications like this, many applications. Okay, phone pay, yes, all these applications can. Yes, to develop this kind of applications, we need some softwares. Yes, to develop such kind of applications, we need some softwares. Those are called as application softwares. Okay. Yeah, this is application software. This is for the purpose of application development. These are the different kind of applications. To develop this different kind of applications, we need some softwares. Okay, fine. Here, application softwares. Examples. Best example: Java. Java is a mostly used application software. Java is a mostly used application software. Java. How do you use application software? Yes, databases also application softwares. Okay, C language application software, C++ application software, Python is application software like this. Yes, .NET is application software. These are different application softwares. Okay, all these are application softwares. There are some examples. Some examples of application softwares. See, yes, around 100 technologies we are using, right? In software field, around 100 technologies, even more than 100 also. We are using many technologies. Yes, all are comes from what? Is it system software or application software? That's a question. Many technologies we are using. Many technologies. Yes, these technologies comes under what? Is it system software or application software? Is it system software or application software? Let us see. See, here we are using some languages like C language, C++, Python, Java, Scala, HTML, like this many application, many languages. Next tools we are using, tools like warehousing tools, like data warehousing tools, like testing tools, AWS tools, DevOps tools, reporting tools like ClickView, Tableau tools. Next packages, some packages like SAP ERP, Oracle ERP, like this. There are different packages. Many kind of things is in it. So which is exactly application software? Simple. Yes, which is exactly application software? See, what is system software? It interacts with hardware components. System software, it interacts with hardware components. See, application software never interact with hardware components. See, any software which is interacting with hardware is a system software. See, any software which is interacting with hardware components, that is system software. Yes, only OS and device drivers can interact with hardware components. Others cannot. Only OS and device drivers okay, interact with hardware components. Of course, device drivers are part of OS. Okay, see here, except OS, all are application software. Simple, very simple answer here. Very simple answer. Yes, except operating systems, all are application softwares. All are application softwares. All are application softwares. All are application software. That's it. Here. Except OS. Except operating systems, all are application softwares. That's it. One second. See, running notes is not necessary to write Java documents. Yeah, this is your class documents. This document for you only. See today topic. Yes, from the introduction, from the beginning. Introduction software. Software is a collection of programs. Yes, software basically two categories. System software, next application software. System software, it interacts with hardware components. Okay, examples. Application software for the purpose of application development. Application software for the purpose of application development. Examples, all the examples. See, except operating systems. Except operating systems, all are application software. Except OS, except operating systems, all are application software. Fine. See, running notes is not necessary. Running notes is not necessary. All are prepared in the document. Everything prepared in the document. All are prepared. Okay. Yes. Now, see, Java comes under application software. Java is application software. Java is application software. See, before going to application software, let us see something about OS. OS. About OS. Yes, something about OS. Yes, what is OS? Let us say about OS here. Yes, about operating system. Here, some question for you guys. Some question. Can we run any program? Any program? Yes, without OS. That's a question. Yes, anyone, can you answer this? Of course, I'll explain. Can we run any program without OS? Can we run any program without OS? Answer is no. Okay. Yes, to run all the programs, yes, we need OS. See, except bias. Okay, except bias. Yes, for all OS request. For except bias. Okay, so except bias for all programs OS request. For all programs OS request. For all programs OS request. What is bias? What is BIOS? Anyone idea? What is BIOS? BIOS stands for yes, basic, yes, basic input, and basic input and output system. Basic input output system BIOS. So what is exactly BIOS? What is exactly BIOS here? BIOS, it's a chip level. It's BIOS is a chip level program. It's a chip level program. Chip level program. Okay, it's a hardware program. It's a hardware program. Hardware program. Hardware program. Okay, hardware program. Okay. See here, what's the role of BIOS in your system? BIOS. What is the role of BIOS? Yes, BIOS. BIOS is responsible. BIOS is responsible. BIOS is responsible for what? Anyone idea? BIOS is responsible for what? BIOS is responsible to yes, responsible for booting ways. BIOS is responsible for the booting ways. Okay. See, once you power on system, first BIOS initiates. First BIOS program activates. That BIOS program is responsible for booting ways. What is booting process? Yes, what is booting process? Yes, booting process is a loading ways from hard disk to RAM memory, hard disk to RAM memory, hard disk to RAM memory. Yes, to run this BIOS, OS is not required. Before OS, first BIOS starting, next later, yes, OS. See, to start OS, BIOS required, first of all. First step, once you power on system, first is BIOS only. BIOS program starts. It's a hardware level program. That BIOS program will load OS in the RAM memory. That BIOS program will load OS in RAM memory. So BIOS program is responsible for the booting process. So booting process is a loading OS from hard disk to RAM memory. Okay, once OS is ready, once OS is loaded, your system is ready. See, once OS is loaded, your system is ready. See, before OS, first BIOS will start. Before OS, first BIOS starts. BIOS is a hardware level program. It's a chip level program. It's a hardware program. Okay. So before the OS, first BIOS starts, next OS. Okay. Just 1 second. Let me have some water. Yes, uploading OS, how that OS is working. Yes, our topic is now OS. Yes, how that OS is working. One second. Let me have some water. Yes. See, suppose your laptop. Yes, your laptop. See, when you purchase laptop, hardware. Yes, on top of hardware, OS is running operating system. Okay, your laptop or your desktop. So first hardware, on top of hardware, yes, OS is running. OS is running. Okay. Suppose learning C language. To learn C language, you have to install C software on top of OS. Suppose C++, you have to install it. Java installing on top of OS. Suppose you want Python. Okay. Suppose Hadoop required, then Hadoop. Yes, all of these things on top of OS. Suppose database using the database also you have to install. See, all these are application softwares. All these are application. application softwares. Yes, all their application softwares. Yes, these application softwares running on top of OS. C program, C++, Java, Python. Yes, all these programs running on top of OS. Running on top of OS. So OS giving platform. OS just it's giving platform. On top of it, all are running. OS giving platform. It's giving platform. On top of it, all are running. So what is OS? It's a platform. Simply here. Yes. What is operating system? 1 second. In font size. Yes. So what is operating system? So what is operating system? Now question is what is operating system? Yes, it's a platform. So what is OS means? Simply here, it's a platform. It's a platform. It's a platform. It's a platform. Yes, where yes we can run all the application softwares, all the application softwares, all the application softwares. Okay, it's a platform. Okay, so what is OS? What is operating system here? It's a platform. Yes, OS acting like a platform. On top of it, all are running. On top of it, all are running here. So OS, it's a platform. It's a platform where we can run all the application software. That's it. See, not only platform here, not only platform. Suppose C program generating some output. So output of C program first of all delivered to OS. Output of C program delivered to OS. After delivered to OS here, then transfer to output device. Similarly, Java program output first of all delivered to OS and then transfer to output device. Suppose reading data from the keyboard. So first the keyboard data goes to OS. First of all, keyboard data, reading data from the keyboard. That keyboard data, input keyboard data goes to OS. Yes, OS to that programs, maybe C program or Java program, something like this. Okay. So between application software and hardware, yes, hardware there's a OS. There's a OS, right? Between these two, there's a OS. Okay, so between these there's a OS, right? Like a mediator. So OS acting like a mediator between these two layers, right? Mediator between these two, like a interface. We can say interface, simply calling as interface. So OS, yes, it is an interface. It's an interface. It's an interface. It's an interface. Yes, between it's an interface between yes. OS is an interface between application software. Is an interface between this application software layer, application software and hardware components. Just interface, just mediate like a mediator. Yes, hardware components. That's it here. It's an interface. It's an interface between these two things. Okay. So OS is an interface. It's an interface between application software and hardware components. So what is OS means? Simple answer. It's a platform. It's a platform where we can run all the application softwares. Next, it's an interface. It's an interface between application software and hardware components. That's it here. Okay. Next, one more. Yes, in OS, there is a library. Yes, every OS there is a library. In every OS there is a library. So what is library? Library is a collection of functions. 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 All the C language functions. See, every operating system, almost all the operating systems, like Windows OS, Linux OS, Unix OS, all these operating systems. Okay. Yes, all these operating systems. Yes, all these operating systems. Yes, almost all these operating systems developed in C language. C language means there are C language functions here. C language, that input output functions. Input output functions. Library is a collection of input output functions. Library is a collection of input output functions to perform IO operations between application software and hardware. So here OS just using library. OS using library to communicate between application software and hardware components. Okay. See, every OS has its own library, yes, to communicate, to communicate, to communicate, to communicate, yes, between application software and hardware components. So between application software and hardware components. Okay, every OS has its own library to communicate between application software and hardware components. Next, one more important point here. See here, one more important point. One more important point. See, these programs like a C program or C++, Java, Python. Okay, all these programs, first of all, links with OS library. Of linking with OS library, then communicates with hardware components. Yes, it has to link. Every program has to link with OS library to communicate with hardware components. So before going to running program, before going to start program, before going to starting program, first of all links with OS library. Of linking with OS library, then program execution starts. First of all, linking with OS library. Every program has to link with OS library before going to start. Okay. See, every program, yes, every program has to link with OS library, library, yes, before, yes, before, yes, before, yes, going to run, before going to run. Okay, it has to link it. See, that link can be static linking or dynamic linking. That linking. So every program linking with OS library, it has to link. It has to link. If this point is very, very important. Java perspective, yes. Java point of view, this point is very, very important here. Very, very important. So every program has to link with OS library. Linking with OS library. Of linking with OS library, then communicates with the hardware components. Fine. That link can be static linking or dynamic linking. Suppose if it's C and C++ is static linking. Java and Python dynamic linking. A static linking, dynamic linking, we'll see next. I'll show practically. Don't worry, guys. I'll show practically. Practically, I'll show it. Yes, later we can discuss. Okay. Yes. In C and C++, statically linking. How? Practically, we'll discuss. I'll take one C program. I'll create some exe file. What happens? We'll discuss very clearly. Java and Python. Yes, here also I'll take some exam, some program. Yes, I will run it. How dynamic linking, those things we'll discuss practically. So this is about OS. Enough. That's all. This introduction is enough about OS. So what is OS means? Is a platform. It's a platform. On top of it, everything is running. On top of it, all are running. Next, it's an interface between application software and hardware components. Next, OS using library to communicate between application software and hardware components. Next, all application softwares have to link with OS library to communicate with hardware components. 1 second. Same points expand here. See, all that 4 points expand here. Okay, all these is there in documents. So running notes is not necessary. Just to go through the document. So this is about OS. This is about OS. Okay. Yes, enough about OS. Java point of view, that is enough. Okay. Yes, Java is application software. Java comes under application software. So let us move to application software. Now, let us move to application software. See, application software. Application software. Okay. See, application software basically two categories: front-end software and back-end software. Application software basically two categories: front-end and back-end. Here, front-end, back-end. What is front-end? What is back-end? Let us see. Front-end, back-end. See, front-end is like this. Yeah, this is front-end. This is front-end. This is front-end. Okay. Yeah, this is collecting data from us, right? Yeah, this is collecting data from us and storing to some location. Yeah, this form, registration form, it's a registration form. Yes, it's collecting data from us. then storing to some location. Okay, so this is called as front end. So front end interact with users. Front end interact with end users. We are the end user of this application. We are the end users. So this front end interact with the end users and collecting data from us and storing it to some backend. Backend is a storage area. Backend is a location where all the information is storing. Okay, see, today you all guys fill this form, right, and registered. Okay, the data goes to some location, storing some area. That location called as backend. So this data maintaining at the backend. Yes, next Durgasoft, they will take all the data and sending follow-up emails. Sending follow-up, right? They will track you. That's it here. So this is front end. Yes, where data storing, that is called as backend. So backend. So front end, backend. See this. Yes, front end. Yes, front end. Yeah, these are to interact with end users. These are to interact with end users. It collects data from end users and stores in the backend. Okay, backend softwares. Backend. These are to store and maintain data. Examples, databases and files here. Databases like Oracle database, MySQL database. Like there are different database files, Windows file system, Linux file system, Hadoop file system. Hadoop file system is to store big data. Hadoop file system to store big data. See, Hadoop. On Hadoop also, I'll take yes, some session on the Hadoop. I'll take one session on the Hadoop. What is exactly Hadoop? Hadoop is very hot in the market. What is exactly Hadoop? So why Hadoop is famous in the market? That also I'll take one day session on Hadoop. Okay. Yes. So front end, back end, fine. Yes, Java is a front end. Java comes on the front end here. See, here this is the form, right? It's a JSP. This form developed in JSP, Java Server Pages. JSP is a Java code. So behind of this form, this is Java code. The Java code reading data. Java code reading data. Java code simply reading data and storing database. So Java comes on the front end. It's a front end. It's a front end. Okay, Java is a front end. So Java is a front end. So let us move to front end. Now front end here. Yes, in front end, there are some languages and packages. In front end, language and package. See, what is a package? Package is a ready-made one. Package is a ready-made one, ready to use. For example, MS Office, next Tally ERP, Tally accounting package, all these packages. Here, no coding, directly can use. Languages, we should write the codes. We should write the codes. Yes, Java comes on languages. Java is a language. So let us move to language. See that way of introduction. How I am introducing you to Java. Yes, introducing you to Java. See, computerware, hardware and software. Java is a software. So started software. In software, system software, application software. So Java comes under application software. So before going to application software, yes, something little bit explained about system software, some idea given, introduction given, and move to application software. Yes, moved. Yes, in application software, front end, back end. Java is a front end. So that's the reason move to front end. Okay, front end language package. Java is a language. So moving to languages. Languages. Yes, let us see. What is language? Yes. What is language? It's a media of communication. Language is a media of communication between two things. Maybe two persons, two animals, or two trees, something like this. It's a media of communication. Okay, languages. Now software languages. Software languages. In software, so what are the languages in the software? Software here, software language. First one is computer. Computer understandable language. Computer understandable. Computer understandable language. Computer understandable language. Second one, yes, user understandable language. User understandable. User understandable. User understandable language. Computer understandable language. Next, user understandable language. Computer understandable language. User understandable language. Yes, user understandable language is like English language. User understandable language is like English language. For example, Java program. Java program is user understandable language. Java program. Support test.java. So this is some Java program. It's looking like English language. Here this is user understandable language. English language is looking like English language. This is user understandable language. Java program. Okay. Next, one more example, Python scripting. Python scripting. Python scripting. Python scripting. See, this also like English language, right? Yes, this is user understandable language. Python scripting, Java programming. Suppose C programming, for example. C programming. C, Turbo C, Bin. Yes, C programming. Yes, all are looks like English language. This is user understandable language. User understandable language. Yes. What is computer understandable language? Computer understandable language. That depends on generation of computers. Generation of computers. Generation. Yes, generation of computers. Generation of computers. Yes, how many generation of computers? Yes, anyone idea? I'm asking about generation of computers, not generation of languages. I'm asking about generation of computers. How many generation of computers? How many generation of computers? How many generation of computers? Yes, Venkatesh, 5 generations. Nalin Saku, 7th generation. No, not 7 generations, 5 generations. 11th generation. Yes, Sandalia, Sai Vivek. 11th generation means, yes, you like that Intel processor, like you saying that i3, i5, i7, i9, something like that. No, it's not that. Computer. Yes, 5 generations. Totally 5 generations. First gen. What is a first generation computer? First generation computer. First gen. Yes. First gen is a first generation. Yes. First generation. Yes. Vacuum tubes. It's a vacuum tubes. Vacuum tubes. Vacuum tubes. First generation vacuum tubes. Vacuum tubes based. Yes. What is second generation computer? Second generation. Yes. Second generation. What is second generation computer? Yes. Transistor based. Transistor based. Second generation transistor based. Yes, vacuum tubes, transistors generally it's electronic subject. See, in our engineering we have one subject, electronic subject. Okay, like a diode and something like some vacuum tubes are there. Okay, yes, long ago. Yes, I studied that subject. Okay, so first gen vacuum tubes, second generation transistor based, third gen. What is third generation computer here? Third gen is IC based, integrated circuits. IC based, integrated circuits. Okay. Next, fourth gen. What's a fourth generation computer? Fourth gen is fourth generation is processor based. It's a processor. It's a processor based. It's a processor based. Fourth generation is processor based. It's a processor based. Okay. Now this is present generation. Now this is present generation. It's a present generation. Fourth one is present generation. Next, fifth gen is a feature. Yes, what is fifth generation computer? What's a feature computer? See, yesterday I told you feature technology. Feature technology. Not quantum. Yes, AI based. Yesterday we discussed a little bit about this AI based. So next is artificial intelligence based here, AI based. Next generation. Now currently here processor based computer. Yes, currently we are using processor based computer. Yes, processor based understandable language. Processor based understandable language. understandable language is binary code. That's it, binary code. Binary code, this is zeros and ones format. Zeros and ones format. Binary code, zeros and ones format. That's it. So this is a generation of computers. I think you guys not expected this much of basics, right? Yes, guys. I think no one expected. No one expected this much of level of basics. Started from very scratch, including computer generation. Started from very scratch. Okay. So processor based understandable language is a binary code. It's a binary code. It's a binary code in the form of zeros and ones. Okay. Yes, it's a system understandable language. Yes, it is a system understandable. It's a computer and system. It's computer system. It's a system. It's processor. It's a system understandable. System understandable. Yes, it's a system understandable language. It is system understandable language. Understandable language. It's a system understandable language. Okay. So this is computer understandable language. This is computer understandable language. This is user understandable language, English. Yes, computer understandable language are called as low level languages. So in software, languages are two categories. First one, yes, low level languages. Low level languages. Second one, high level languages. High level languages. High level language. Low level and high level languages. Low level and high level language. What is low level language? Low level language. It's a system understandable language. Low level language. Yes. It is a system understandable. It's a system understandable language. It's a system understandable language. Okay. Here system is processor. System means here. System means processor. It's a processor. Processor understandable language. System means it's a processor. See, processors initially 8085 processor. Now we are using 8086. Yes, before 90s 8085 processor. Before 90s. From 90s 8086. From 90s 8086. Okay. System is a processor. Processor understandable language. Okay. Yes, it is in the form of binary code. It is yes in the form of binary code. In the form of binary code. In the form of binary code. Like a zeros ones format. Like a zeros ones format. Yes, it's a zeros ones format. Yes, yes, it is a yes, yes. It is called as machine language. It is called as machine language. Simply calling as machine language. It's a machine language. It's called as machine language. That's it. It's called as machine language. Low level language. It's called as machine language. Next, high level language. About high level language. High level language. It's a user understandable language. High level languages. It's a user understandable language. High level language. Yes. Yes, it is a user. Yes, it's a user understandable language. Understandable is a user understandable language. It's user understandable language. Okay, it is like English language. It is like English language. Like English language. Yes, language very easy to understand. This very easy to understand. Very easy to understand. Very easy to understand. Very easy to understand. It's very easy to understand. Yes, which is first a high level language? Anyone idea? Which is a first high level language? Which is first high level language? See, many high level languages are there. Java, C++, C language, Python, Scala, HTML. Yes, all these are high level languages. Which is first high level language? C language. Yes, C language. C language. Yes, C language. C language. C language is a first high level language. First high level language. High level language. C language is first high level language. High level language. Yes, developed by whom? C is a first high level language. Who has developed C language? Developed by whom? Yes, we has developed C language. Yes, good, good. No, Charles Babbage is the inventor of the computer. Charles Babbage is the inventor of the computer. Who invented the computer? Charles Babbage. Computer invention by the Charles Babbage. C language for the Dennis Ritchie. Dennis Ritchie. C language for the Dennis Ritchie. C language for Dennis Ritchie. C language is first high level language developed by Dennis Ritchie. Yes, in the year 1972. Yes, first high level language C language. Yes, first high level language C language. Yes, after that C++. After C language, next C++. After C++, next to Python. After Python, other language like COBOL, Pascal, Basic, Fortran, mini language. Next Java language. Okay, see. Yes, Fortran, Pascal, Basic. There are many languages. They are not official languages. Official languages. C is a first official language, officially using C++, officially using Python, officially using COBOL, officially using. Next after that, yes, sir. Java officially using here. Okay, next .NET, like this one by one, all the languages. C is a first high-level language. C is a first high-level language developed in the year 1972. That's it. So this is about low-level language, high-level language. Your question is here. Some question here. See, Java program system cannot understand Java program. The Java program has to convert into that system understandable language, means binary codes. This Java program has to convert into binary codes. Okay, suppose here Python script. This Python script has to convert into binary codes. These are all the high-level language. High-level language to binary code. Who will convert it? High-level language to binary code. High-level language. Yes, high-level language program. High-level language program to binary codes. Binary codes. Binary code. Yes, which one will convert here? Tell me. Yes. Which is responsible to convert from high-level language to binary code? Yes, which is responsible? Tell me. Yes. Yes. High-level language to binary code. Yes. Either interpreter or compiler. Either interpreter, yes, or compiler. Either interpreter or compiler. Either interpreter or compiler. Compiler. Either interpreter or compiler. Converts. Converts. Yes, converts. Converts. Converts from high-level language to binary code. Binary code system understandable language. Okay, either interpreter or compiler converts from high-level language to binary code. High-level language to binary code. High-level language to binary code. Interpreter or compiler converts from high-level language to binary code. Okay, not JVM. Not JVM is different. JVM task is different. JVM task is different. Yes, either interpreter or compiler converts from high-level language to binary code. Okay. See, now we'll be discussing about interpreter and compiler. See, 1 second. See, as a part of our discussion, yes, we is discussed. Now we are going to discuss about interpreter compiler. Next, execl.test. Once these topics completed, then easy to understand these things here. Java features. To understand Java features here, these are all these basics required. Once you good at these basics, then easy to understand these concepts here. See, directly I can explain these things here, but cannot be understood. You can't understand. So for that reason, I'm explaining all the basics. Okay, all that basics. Yes, now interpreter and compiler. Yes, what's the difference? Anyone? Yes, anyone idea about interpreter and compiler here? Interpreter versus compiler. Let us see about interpreter versus compiler. Yes, anyone idea? Yes, what is interpreter? What is compiler? Yes, interpreter step by step. Okay, good, good. Compile is whole program. Interpreter translates only one statement. Okay, good. Yes, yes, good response. Interpreter line by line execution. Good. Nilesh Kumar, good. Yes. Okay, let us see. Interpreter for interpreter purpose. Yes, interpreter purpose. See, I'm taking Python script. Python. Python is interpreter based language. Okay, Python. Suppose test.py. Python script file. Python script. Python script. Python script. See Python. Mn Python. Here it's a Python script. Test.py file is there. Yes, Python. Generally, Python development for this purpose. PyCharm is. I'm using PyCharm. Yes, in our office we are using PyCharm for Python part development. PyCharm. Yes, PyCharm little bit difficult to understand. So better go with yes command prompts. Yes, let us go with command prompt here. C drive, mn Python. Yes, this test.py file is there. Okay, command prompt cmd command prompt. Open command prompt. From that go to D drive. D drive. D drive in that mn Python. Yes, dr mn Python. It's a directory. Dr means directory. Now changing to mn Python. Yes, Visual Studio Code also you can use for Python. Visual Studio Code you can use, or you can use even Eclipse also you can use. Okay. Yes. See how it is command prompt. See exit. Open CMD. Command prompt opens. So next where we should go to where D drive mn Python. This location. D drive. Yes. D colon. That will take to D drive. D drive. Now your D drive. DR means that all that contents. DR. All that contents. DR. That contents. These are all the contents, right? Okay. So DR means directory. Directory folder both are same. See this. MN Rao, MN Rao Advanced Java, MN Rao AWS. See all are starting with MN Rao. These all are directories. See same thing here in GI, D drive, MN Rao. Yes, all the folders, right? Starting with MN Rao, all the folders. Folder directory both are same. In GA calling as folder. In GA it's a folder. These are the folders. These are the folders. It's a folder under the subfolders. So in GA folder, graphical user interface. GA means graphical user interface. No, it's a character interface. CUI or command line interface. So they are called directories. Same thing directories. Now mn Python is a directory. mn Python is a directory. Now how to go to that? CD means change of directory. Change of directory. mn Python changed. Okay, changed. CLS clear the screen. Not DR its contents. See here. This is test.py file. Yes, let us open with Notepad. Notepad. Yes, test.py. Test.py. Yes, it's open here. Now this Python script. Python script. Yes. How this script is working here? Yes, Python is interpreter based language. Python is interpreter based language. How Python interpreter is working? Let us see. See, first A equal to 10. Yes, B equal to 20. C equal to A plus means addition. Next subtraction. Next multiplication. So program to add, subtract and multiply two numbers. Addition, subtraction, multiplication of two numbers. Two numbers. Okay. Yes. Now the script running directly. Python script running directly. Python, yes, program script execute directly here. Suppose if it is C program, we should compile it first of all. If it is C program, first compiling, error checking, if no errors, then execution. But Python is not like that. Python is not like this. Directly submission. Directly running. No errors checking, nothing here. It's interpreter based language. Interpreter based language, direct execution. No errors checking. No errors checking here. Okay. How this interpreter working? Yes. On Python codes, how that interpreter is working. Interpreter. How interpreter working? Let me explain. How interpreter working? How interpreter working? How interpreter working? How that interpreter is working here? Okay. See, Python codes. So first statement, suppose A equal to 10, yes, B equal to 20, next C equal to A plus B, next printing, yes, that addition value here, next subtraction performance, yes, next, yes, displaying subtraction value, next multiplication operation and output. Like this, there are some statements. So Python script statements here, some script statements. Okay, yes. How that interpreter is working? Let us see about interpreter. How this interpreter working on all the statements? See, interpreter first of all checking for the first statement. Suppose first statement is correct. First statement is correct. If first statement is correct, then interpreter immediately converts. 1 second. Yes, if first statement is correct here, correct, then interpreter converts that first statement to binary codes. Binary code immediately converts into binary codes. That first statement convert into binary format, that binary format given to processor. So processor taking that codes and generating output, executes and generating output. 1 second. See, next coming statements may be right or wrong. Next coming statements may be right or wrong. Interpreter never think about next coming statements. Suppose if statement, if it is correct, immediately converts into binary format and given to processor generating output. So first line over, first line correct, execution completed. Next after that, next statement. Checking for next statements. Suppose next statement also correct, same process. Next statement also same, converts into binary code. Just converts into binary code. Next statement also same, converts into binary codes and given to processor. So getting outputs. Okay. So checking for next statement. Suppose next statement here, next statement, something wrong, simply stops. Something wrong, interpreter stops. Yes, if any error comes, interpreter stops. Okay. Yes, it won't go to next lines. It won't go to next statements. Once error comes, simply stops. Once error comes in, interpreter stops. Let me show that practically. See, A equal to 10, that's okay. B equal to 20, C equal to A plus B. Suppose here, comma missing. Suppose here, bracket missing. Okay. Suppose here, double quotation missing. There are three mistakes, right? Three mistakes. Okay. Save and close. Okay. Now running program. Let us run this. Let us submit this. Yes, Python. Yes. See this. Only one error showed. Next error is not displayed, right? Only one error. Any error comes, interpreter stops. Any error comes, interpreter stops. Any error comes, interpreter stops. That's it here. Okay. See here. What's happened here? So this is correct. This is correct. This is correct. Here error here mistake. Simply stop. Yes, it's not checked. Next coming statements not checked here. It is not checked. It is not checked. Here only stopped. Here only stopped. Here only stopped. 1 second. 1 second. 1 second, just I'm taking some water just. Yes, here error, simply stop it. Yes, even it's not checked other errors, right? Only here stop. Yes, that is working of interpreter. Any error comes, interpreter stops. Any error comes, simply interpreter stops. Any error comes, yes, interpreter stops. Okay, so here stop, right? Just stop it here. Okay, CLS, here stop it. 7th line error. Okay, no, correct that mistake here. Suppose, comma, save, and exit. Yes, now again, see this. Now 11th line error. So only one error showing here. Any error comes to be stopping here. 11th line error. No correction of that error. 11th line error. Correction of that error. 11th line. So this bracket missing, right? Yes, correction. Okay. Yes, no. 1 second. Run it. See this. So again, 15th line error. See, I'm using up arrow key. Yeah, this command prompt will maintain history. Up arrow key. I'm using up arrow key. Up arrow key. Arrow keys. Okay. Down arrow key. Up arrow key. Yes. It will maintain the history of commands. History. Here typing every time instead of typing already executed commands, right? Executed commands. You can get history up arrow key. Yes. That 15th line error. Now up arrow key notepad. Yes, notepad. Yes. Now here error message. Double quotation here error. Okay. Exit. Yes. Now run it. Yes, that's it. Okay. So how it's working? Yes. How this interpreter is working here? Line by line, checking first line, then execution. Next line checking, then execution. Over, first line over, next line over. Yes, next coming statement may be right or wrong. Never think about next coming statements. If it is correct, completion here. If it is correct, next execution, giving output. So line by line. Yes, any error comes, simply stops. Any error comes, simply stops. This is interpreter. Yes, compiler. How compiler working? Let us say about compiler here. Compiler. For the compiler, yes, let us take C program. Compiler, if it is compiler, let us take C program. Compiler. Compiler. Yes, C program. Let us take some C program. C program. Suppose test.c or some C program like this. C program. Yes. How compile is working here? C program. Compiler checking first statement. Suppose first statement is correct. First statement correct. Even correct. Yes. It won't convert into binary coding. No. No, it won't convert. It won't convert into binary code. Even the statement is correct. It won't convert. It won't convert. It won't convert. Checking for next statement. Next statement also correct. Yes, even correct. It won't convert. Suppose next statement something wrong. Error at third line. It shows the error at third line. After that, checking for next statement also. Okay, if it is correct, then checking for next statement like this. Compiler checks the whole program from top to bottom. Yes, it checks all statements from top to bottom, all the lines from top to bottom. Suppose one more error. Yes, error at some line here. Next error. Okay, so checking for next statements. Checking for next statements. Okay, yes, checking for next statements. Checking for next statements. Checking for next statements. Checking for next top to bottom. Compiler checks the whole program from top to bottom. Compiler checks whole program from top to bottom and shows all the errors. These are the errors. For example, yes, compiler, it checks whole program from top to bottom and shows all the errors. And shows all the errors. Okay, yes. 1 second. Let me show that compile the example also. C program, Turbo C. Yes, Turbo C language. Here, this is the program in this main function, main. Yes. See, all compile, only compile. Now see compile option. Success, no errors. Okay. Run. Yes. First number 10, second number 20. Addition, subtraction, multiplication. This is program. Now some mistakes here. Suppose here semicolon missing. Suppose here bracket missing. There are some mistakes here. Okay. Suppose here comma missing. Okay. Suppose here semicolon missing. Suppose here double quotation missing. Some mistakes. Okay, print of bracket missing. Suppose here bracket missing. Okay, suppose here semicolon missing. Okay, now file menu, save, saved, program saved. Now compile, just compile option. Enter key. Errors. How many errors? Total 9 errors. Compiler shows all the errors from top to bottom. Interpreter is only one error. Interpreter is only one error, but compile is all errors. See, press any key, any key, just enter key. See this first. Yes, line number 16. Declare syntax error. Next, down arrow series. 18th line error. 22nd line error. See at the bottom. 27th line error. 29th line error. 31 line, 33, 36, 40 like this. All the statement from top to bottom. Compiler shows all the errors from top to bottom. Compiler checks whole program from top to bottom and shows all the errors. So this is working of compiler. It shows all the errors. Now correct all the mistakes. Just you correct all the mistakes. Correction of all the mistakes. Suppose here semicolon missing. Let us correct all the mistakes. After correction, what happens? Yes, correction of all the mistakes. Correction. Okay. Yes, comma missing. Yes, compile. Still errors. 5 more errors. Yes, bracket missing here. Okay, next. Yes, next here double quotation missing. Here double quotation missing. Yes, compile. Still 2 more errors. Yes, here semicolon missing. Semicolon missing. Still 1 more error. Yes. So here printf bracket missing. Compile. Yes, success. Success. No error sites. Yes, compiler checks whole program from top to bottom. Compiler checks from top to bottom. Okay. Yes. Next, we should correct all the errors. Correction of 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 all the. Suppose no error. Next time no error. What happens? Correction of all the errors. Yes, correction of all the errors. Okay. Suppose if no errors, what happens? What is next step? If no errors, if everything is fine, then compiler opens another file, one more file. It opens another file. Compiler opens another file. It opens another file. Compiler opening another file. After opening another file here, this whole code, top to bottom, all the lines converts into binary code and write to that result file. Binary format, write to this result file. Binary code, convert into binary code and write to that file. Convert into binary code, it converts into binary code. It converts into binary code. Just converting to binary code. Converting to binary code. That whole program converts into binary code. Just code converts into binary code. Okay. All this code converts into binary format. Yes, all this complete code converts into binary format. After converting to binary format and write to another file. Yeah, that file is called exe file. It's called as exe file. Exe means executable file. Executable file, generating one executable file. That executable file given to processor. So processor taking that exe file and executing, generating output. That's it. Generating output here. So compiler checks whole program from top to bottom. If no errors, generating one exe file. That exe file given to processor. So processor executes and generating output. That's it here. Now let us see that exe file. Where they're generating. See backend of this program. Backend. C drive. Turbo C. Bin. Inside of bin. Yes. What is that file? Math.cpp. File name is math cpp, C language, both are same. Math.cpp. math.cpp. Yes, math m. Okay, here 1 second. See here, this math.cpp file backend. Just opening the file here. See this main function. Yes, all this set. This is backend program. That program. Okay, right. Yes, now here this is compiling. Just I'm compiling this program. When compile this program, what happens? Let us alt C compile success of alt or run. See, when you run this, something happened at background backend here. Run this, see this. Yeah. Some file created 10:23 p.m. 29th December at 10:23. Yes, some file math.exe file created. Application means exe file. This exe file. See, right click properties. You can see that properties. Yes, .exe file. Reset 1 second. Right click on it. Properties. Math.exe file. .exe file generated. Executable file generated, right? Just .exe file generated. .exe file generated. After generating .exe file, yeah, that exe file now it's working here. See, first number 10, second number 20. Yes, output is like this. Addition, subtraction, multiplication. That's it. Okay. So what is happening here? Yes, compiler generates one exe file. After generating exe file, execution finally generating output. That's it. So this is difference between interpreter and compiler. Okay. See. Yes. Let me explain points. Points wise, then easy to understand this one here. Yes. Interpreter and compiler, the differences. See, interpreter, next compiler. Interpreter and compiler. Yes, interpreter and compiler. Interpreter and compiler. What's the differences here? What's the difference? Interpreter, compiler difference. See, interpreter. First difference. First one. Interpreter checks the code line by line. First line checking, then execution. Next line checking, then execution. It checks the code line by line. Interpreter checks the code line by line. Compile this whole program. Yes, checking whole program at a time. Okay. So interpreter checks the code. Interpreter checks the code line by line. Compiler whole program at a time. Yes, compiler checks whole code top to bottom at a time here. Yes, whole program from 1 second. Compiler checks whole program from top to bottom, from top to bottom. Interpreter is line by line. First line checking, then execution. Next line checking, then execution. But compiler is not like that. Whole program from top to bottom. Okay. Next, interpreter generates output generation. It generates output line by line. Output of line by first line output, next line output. Any error comes, simply stops. But compiler is not line by line. Compiler creating one exe file. That exe file executing generating output at a time. So at a time output. This at a time output here. Is at a time output here. At a time output. It's at a time output. It's at a time output. At a time output. It's at a time output. Okay. Yes. Next here. Any error comes, interpreter stops. Any error comes, interpreter stops. It shows. Yes. It shows only one error. It shows only one error. Yes, compiler. All the errors from top to bottom. All the errors from top to bottom. From top to bottom. It shows all the errors from top to bottom. Yes, interpreter. It shows only one error. It shows only interpreter. It shows only one error. Compiler. It shows all the errors from top to bottom. Next, Most important difference is, yes, interpreter, it generates exe file. No, sorry, it does not. Interpreter, yes, it does not generate exe file. It does not generate exe file. Okay, interpreter does not generate exe file. Compiler, yes, it generates exe file. This is main difference. It generates exe file. Yes, what's the main difference between interpreter and compiler? Exe file is the difference. Yes, interpreter based language don't have exe file. Okay, see, interpreter based interpreter. Yes, interpreter. Yes, interpreter based language. Yes, interpreter. Yes, interpreter based language. Interpreter based language. Yes, interpreter based language don't have exe file. Don't have exe file. Interpreter based language don't have exe file. Here everything is exe file. Compiler based, yes, everything is an exe file. First is generating exe file, then execution. Okay, so compulsory exe. Compiler based compulsory exe here. Exe generation then execution here. Interpreter based language don't have exe file. See, interpreter based language, they are called a scripting language. They are scripting language. These are scripting language. Scripting. These are scripting language. They are scripting language. Scripting language. Next, these are programming language. They are programming language. Programming language. Programming language. Okay. So interpreter based language are scripting language. Compiler based, these are programming language. Interpreter based is scripting language. Compiler based programming language. Scripting means that can be modified anytime. Scripting can be modified anytime, but programming cannot be modified because it's exe. How can you modify exe file? You cannot modify exe file. You cannot modify exe file. Cannot be modified. Okay, scripting means anytime can modify. Next, one more difference here. Yes, interpreter based. Yes, it executes source code directly. Source code directly. It executes source code directly. See that source code. Python. In case of Python, see that Python. Yeah, these are source codes. It's a Python source code, right? Python source code. Yeah, the source code executing directly. No errors checking, nothing. No errors checking, directly execution here. Yes, no exe file. Directly our source code means your program called a source code. We are writing that English language code, right? That is called a source code. Yes, it executes source code directly. It executes source code directly, but compiler here, it executes. Yes, executes exe file. Okay, it executes source code directly here, but compiler, it executes exe file. See, interpreter based language examples. Python is the best example of interpreter based language. Python, HTML is also interpreter based language. Linux shell scripting is interpreter based language. Next, JavaScript is also interpreter based language. JavaScript is not a Java. JavaScript is not a Java. JavaScript is a browser understandable language. Java is a JVM understandable language. JavaScript is a browser understandable language. Java is a JVM understandable language. JavaScript executing at the client side. Java program executing at the server side. Of course, the topics later we'll discuss. Later we'll see. Next, compiler-based examples. C language. Next, C++ and .NET. These are compiler-based examples. Okay, interpreter-based and compiler-based. Fine. So this is difference between interpreter and compiler. Main difference is exe file. Interpreter does not generate exe file. Compiler generates exe file. Yes, here many are thinking that this trainer explaining about all of these things. Interpreter based language, compiler based language, all this very clearly explained. Yes, where is Java? Yes, he is not talking about Java. Now Java, is it interpreter based or compiler based? Yes, that we should discuss. Java interpreter based or compiler. For this purpose, yes, you must have how Java program is working. Okay, like C program explained, right? How C program is working. Compilation, Then creation of exe file, execution. The steps expand. Interpreter steps expand. Same thing, Java steps I should expand. Once I expand Java steps, you can understand, you can decide it. Is it interpreter based or compiler based? Okay. So the topic tomorrow we'll discuss. Tomorrow, first of all, I'll explain about Java. Tomorrow starting Java concepts. Tomorrow, Java starting and next installations and programming starts. Okay. So Java, how Java is working. Java, is it interpreter based or compiler based? That you have to decide. Tomorrow I'll explain very clearly about Java. After explanation, you decide it. You decide it tomorrow. Okay. Yeah, that's all for today. Yes, any doubts? That's all for today, guys. Any doubts? Yes, one second. For our batch, yes, that WhatsApp group created. So this is WhatsApp group. See, yesterday's session already shared in the group, WhatsApp group. Yes, you can click on this, you can watch it. Yesterday's session and first day session, 27th session and next 28th session, today 29th. Yes, by 11 o'clock I'll share it. See, this is by 12 o'clock shared yesterday. At 12 o'clock this was shared yesterday. Today also by 11 o'clock I'll share. By 11 o'clock I'll share it. Okay. Still anyone to submit your details? Yes, this is my WhatsApp number. Yes, 8179189123. Yes, your name. Yes, and your Gmail ID. Your name and your Gmail ID. Submit it. Yes, I'll add to group. Okay. Tomorrow I'll create a yes, drive already created. Drive already created here. So tomorrow I'll share the drive link. Okay. Yes. Any doubts? See, one second. Yes, some request from the online team. Yes. So online team requested. Yes, requested me to ask our fee payment. Just inform our fee payment. Please, you guys, if possible, try to pay the fees. Yes, no worry. See the classes 3 to 4 days. After that only you can pay the fee. Yes, if it is okay, then you pay. Try to pay it. Maximum try to pay it here. Okay. Even you can check it. You can see classes 3 to 4 classes. You can see. So next 2 classes you can see. Then you can decide it. Okay. Suppose if you feel good, if you're good at this here, you can pay tomorrow. Tomorrow morning you can pay. Okay. Yeah. Yeah. This is my WhatsApp. And still anyone to share these details, share it. Okay. Yes. Tomorrow also same link. Tomorrow also same link. No change in link. Tomorrow also same link. Yeah. Okay. Yeah, that's all. Let us wind up session for today. Let us wind up session for today. So thank you guys. Just see you tomorrow.